I've been doing some research and come across some conflicting information, so I was hoping you could clear some things up for me.
I'll sure try.
One big thing I've heard is that high voltage testing is destructive, that it destroys motors. Is that true?
Well, we get that question a lot, and it's not true. And the reason is that motors see high voltages every time they start and stop. And the standards that have been around for even longer than we've been a company all promote high voltage testing. And they would never promote high voltage testing if it was destructive testing.
Why do you do high voltage testing?
Good question. So where does high voltage come from? I mean, you think on a 480 volt motor, a lot of the standards will recommend somewhere around like 2,000 volts.
Wow.
Well, so like on a 480 volt motor, you've got your basic insulation, copper to copper, and you have your insulation to ground. So you have an inductive circuit. And when you start a motor, you got your contactors that open and close. So you establish a circuit, and then you instantaneously break it before making contact again. So it's when you break that inductive circuit is when you get your high voltage spike. So most people know about that, that work around motors know about the current that you see on start, 6 to 10 times operating current. And that's because you have an inductive circuit that can't be energized instantaneously. But not as many people know about the voltage spike that happens right after that. And again, that's because of you're breaking this inductive circuit. You have this magnetic field that forms, and then it collapses. And when a magnetic field collapses, it induces a voltage back into the circuit. So that's kind of the simple physics of what happens. So you get this inrush current, then you also get this voltage spike on startup. I mean, the insulation has to last for many, many years, and has to be able to withstand not only these voltage spikes, but all the other things that wear insulation down, like chemical aging, heat, and mechanical movement and friction. But the voltage spikes are kind of interesting because a lot of people don't realize where it comes from, and therefore why the standards exist, and why we do high voltage testing.
So your tests are basically the same thing as starting a motor?
Not exactly. So when you start a motor, you do have the voltage spikes, and that's again why we do high voltage testing. But what you do not have with testing that you do have when you start a motor is all the energy and the current. So for example, even like a high pot test, a DC high pot test, which we do, that's microamps is what we're using to monitor the resistance. So a real startup uses, again, 6 to 10 times operating current. So you're talking, several hundred amps in many cases compared to microamps. So you don't have the energy and we don't have the current in the test equipment. We only need voltage to expose the problem. So we don't need to simulate a true startup in order for these to be effective tests.
Oh, so it's low energy, so it's not going to damage my motor.
Yeah, exactly. Yep.
So are there any standards that dictate these tests?
Right. So the standards, and that's really good news for both us as a company and you as a potential customer, is that you don't have to believe me or the company I represent. The standards have been around and they're peer reviewed. So they're not just one company saying, hey, here's what you should do because we think this is what you should do. These are international organizations that have been around for decades. And again, they're frequently, the standards are reviewed. So some of the acronyms are like IEEE is one we reference all the time. NEMA is another reputable organization. IEC, which is more common in Europe, but they have very aggressive standards actually. And also ESA, which is for the motor repair industry. And another one is the NFPA, National Fire Protection Association. They promote high voltage testing as well. So they all are in the same ballpark. If you're doing something above operating voltage, you're going to find things that you just can't with low voltage equipment.
So won't my Megger find these problems?
So the Megger it's a very good test, and it's very, very widespread. Almost every electrician out there or engineer, they know what a Megger test is. And Megger is actually a company name, but we affectionately call it that. But the Megohm test is, so I've got a piece of insulation to ground here, and then of course your copper to copper insulation. If you imagine a stator, it consists of a laminated iron core. The main component of ground wall insulation consists of slot liners, which are inserted before the windings are installed. The windings consist of copper wire, which is coated with an insulating layer. This comprises the turn-to-turn insulation. finally, additional insulators known as top sticks complete the ground wall insulation. When you perform a megohm test, it's typically done at operating voltage. So for a 480 volt motor, that's done about 500 volts. We just round it up to make it easy. What you're doing is putting a DC voltage across your coil. So there's no voltage difference from turn to turn. So it's basically all one big piece of copper. All right, so you're not checking for problems between turns at all with doing any kind of DC test, which is a megohm test is the most common. So this is what you're actually seeing if there's any leakage current going through this, if you have a little pinhole, or if you have an artificial path with some contamination that allows it to go around the insulation to ground. So you're just seeing if there's anything getting through this or around this insulation by doing your megohm test. What it does not do, though, so not only does it not check this insulation to the levels that I just talked about that the motor sees when it starts and stops, it doesn't check your copper-to-copper insulation at all. So probably the easiest example I can give you why a megohm test is not adequate at finding a lot of these problems is most often when a motor trips offline, it's when you start it. That's when you notice it because it trips and doesn't run. So I've witnessed this many times myself where you go out and a motor's tripped offline and you do a megohm test and it passes the test. But then you take that same voltage up, DC voltage, you take it up a little bit higher, what we would consider a high pot or high potential test, and it finds the problem. And just simple physics, the megohm test is performed, say right here, the high pot test is performed up here, and that's where the motor just saw that voltage when it tried to start. And so what happens is if you're only doing megohm tests, you're never going to see the problem unless you either get that voltage up to the level which the motor just failed at or tripped at, or you let that failure come all the way down months later to where you're going to be testing with the megohm test. It's too late. That's an autopsy test at that point.
So as a maintenance manager, say we find a motor that fails a test, do I have to decommission that motor right away?
No, that's the good news. So this is predictive. Some of the tests are certainly great for troubleshooting, and they can be, if you got a situation where something has already happened, yes, you can verify what may have happened, whether it's shorted turns, insulation to ground that has failed, or whatever the case may be. But the whole point of doing a lot of these tests, especially the high voltage tests, are to be predictive. And the reason it's that way is because you can literally find problems months before they, up here, these higher voltages, before they work their way down to where the motor is running. So, for example, on startup, when you start the motor and it sees high voltage, you could have a weakness that develops very easily over time in your copper windings. And that will show up as arcing in one of the tests, the surge test, when you perform these routine maintenance tests, maybe once a year, maybe twice a year, whatever the situation might call for. But the whole point is you can detect that problem, and then the motor, the voltage settles down at operating or steady state voltage, and it runs fine. And that problem never shows up in the operation of the motor. And it'll last for months and months and months like this on a normal operating motor. And what will happen is eventually, it'll that problem will still get worse and worse just through, starts and other environmental factors. It'll eventually turn into a solid welded short. And at that point, your motor only has a few minutes left on it because with shorted turns, you have a tremendous amount of current and heat that eventually burn through the ground wall within just a few minutes. So what happens is you need to find this problem to be predictive. You need to find it months prior to that situation. So the surge test does put a voltage difference turn to turn, just like the motor really sees in a startup situation, to be able to detect problems in the copper windings. And then the high potential test is another high voltage test that checks your insulation to ground to the adequate levels to find problems early enough where it can be a predictive test. And in troubleshooting also, it's very effective. The one scenario I just gave you where your motor trips offline, you can find it in a troubleshooting sense very easily.
Great, Scott. Well, thank you for the information.
Jimmy, thanks for your time. I really appreciate it. Have a good afternoon.